Representation of data. There's quite a few ways we can represent data. We can use box plots, we can use cumulative frequency diagrams, we can use histograms. So there's quite a few ways to represent data. Venn diagrams, another way of representing data. So all the different representations you could be assessed on. What you will also be asked to do is also compare two data sets given the representation. So you might be given two cumulative frequency diagrams and asked to compare them. So first of all, let's take a look at an example of a typical exam question on representation of data. What you tend to get is something involving maybe a histogram. So we'll look at that one question like that. And in terms of comparing data, you'll be essentially asked to compare two things, the location as well as the spread of the data. We're looking at the variable y, which is measured to the nearest whole number. 60 observations were taken and are recorded in the table below. And we can see here the boundaries 10 to 12, 13 to 14. So it's kind of for whole numbers. So if we need to do something in terms of continuous data, we'll have to do a continuity correction. It goes on to say, first of all, write down the class boundaries for 13 to 14. So if we are doing a continuity correction here because there is a missing gap from 12 to 13, for part A, it will be simply just writing down 12.5 going to 14.5 would be the class boundary for 13 to 14 after you do the continuity correction. It goes on to say a histogram was drawn and the bar representing 13 to 14 class had a width of 4 centimeters and a height of 6 centimeters. So we need to use this information, go line by line, and we'll look at the question in a moment. Okay. One of the important things about remember to recall from histograms is that the area of a histogram is proportional to the frequency. So that's what we're going to use to try and work out what the bar size is and so on needs to be. So what we'll do here is we'll draw a bar first of all, just a random bar for the information given. So first of all, let's look at the width of this bar. So they tell us that the histogram was drawn and the bar representing to 13 to 14 had a width of 4 centimeters and a height of 6 centimeters. So I'm going to first of all, I'm going to draw the same bar, but I'm going to draw it using two types of information here. So first of all, I'm going to use the 12.5 to 14.5, that class width, which is for that one here. And so what is that class width? We can see that the class width is 14.5 minus 12.5. So that's 2 here is the class width. Okay, and this is in terms of whatever we are measuring, the y, whatever happens to be. Okay, so it's referring to the y values here. Okay, so y is equal to 2. And then for that same one, they tell us that this bar has a width of 4 centimeters. So I'm going to write down 4 centimeters here is the actual width of it. And this is in terms of class width, which we worked out by doing 14.5 minus 12.5. Okay. Now, this bar also has a height of 6 centimeters that they told us. So I'm going to put that down in the second bar. They're both the same bar, but I'm representing it in slightly different ways. So the area of this bar, 4 times 6, gives us 24 centimeters squared is the area of that. Now, we can also work out what, in terms of actual frequency density, because in a histogram, this height would be the frequency density if we were to draw that. So what would be the frequency density for this one? Well, we know that the frequency density is worked out by doing class width divided by the frequency. So that particular frequency density for this one is going to be frequency density is equal to its class width, which we know to be 2. divided by, oh, sorry, I did it the wrong way around. It's frequency divided by class width. So its frequency here, which we know for this one is 24, divided by its class width, which we know to be 2. So that gives us a frequency density of 12. So we know that this frequency density here and that was the class width. So for that, we can see that the area of this, in terms of the actual frequency, the area of a histogram represents the frequency. So that area is 24, 12 times 2, 24, which is what the frequency is. Okay. So we've got 24 there, which is the frequency. So we've got two bars here. One in terms of the actual centimeters measurements, and the other in terms of frequencies and class width. So we can then compare. We remember area is proportional to the frequency. So the area of the actual bar is 24. It's proportional to the frequency. So in this case, it's actually quite a nice direct proportion here. Each centimeter squared represents one frequency. So it's quite a straightforward one, this one. So what I'll write down here is I'll set up multiplicative reasoning. 24 centimeters squared is equal to 24. What we're talking about here, we're talking about 24, does it tell us? Variable y, 60 observations. Yeah, it doesn't really mention. So 24 centimeters squared is equal to 24 observations, I can say here. So then from there, I know what one observation is equal to 1 centimeter squared. So let's go and take a look at the actual question here. The question goes on to say for part B, for the bar representing 15 to 17 centimeter class, find the width and the height. So for part B, I will do a similar thing. Okay, so this was necessary. All of this I used to simply work out this, which I'm then going to use for part B. So now for part B, I'm going to draw a bar. Again, two bars, one which is going to have my centimeters and one which is going to have my frequency density and class width. So for this bar, it's the 15 to 17 class. And again, the 15 to 17 class, we can see has a class width of 3, because it's going to go from 14.5 to 17.5. So be careful, this one has a class width of 3. So I'll write down here class width is equal to 3. What is the frequency density? Well, we can work it out from here. It's the frequency divided by the class width. So it's 18 divided by the class width, which is 14.5 to 17.5, which is 3. So 18 divided by 3 is 6. So the frequency density we can write down here is 6. So what is the area of that? Well, 6 times 3 is 18, is equal to the frequency as we expect. Now, we want to go and represent this, and we want to find out its width and its height. Okay, so what is going to be its width, first of all? Well, let's take a look at what the previous one was. Previous one had a width of 2 to represent, the width of 2 was represented by 4 centimeters. So everything's going to be in proportion here. So how do we go from that to that? Well, it's kind of working out, well, the class width here is 3 on this one. How do we go to the actual width of that? Let's look at the scale factor. So to go from that 2 to that, it was times by 2. So likewise, I would use the same scale because it's the same histogram, so everything has to be scaled. So this width will be proportional as well to that scale factor. Times that by 2, so that gets me a width of 6 centimeters. Okay. So remember, if the frequency here is 18, then we know then this one's units is also going to be 18 centimeters squared by using this, that 1 centimeter squared is equal to 1 observation. And I've got frequency of 18, so that's going to be 18 centimeters squared as I expect. So what's this height needing to be? Let's figure this out, what this height needs to be. And you can do a similar thing here. So find out what the scale factor is for the frequency density here. So to go from frequency density to the actual height here, it's dividing by 2. So we would do the same thing here, 6 divided by 2. And that would get me 3. So then I get that height as well, which is 3 centimeters. And I can see that 6 times 3 gets me the 18, which kind of confirms everything. So it's another check there. So it's kind of using scale factors. Draw 2 bars, one to represent the frequency density and class width for the height and the width. That's the one on the left. And the one on the right is the actual height and the width in centimeters. Okay, and we're setting up an equivalence and we're looking at what the scale factor is. So then Going back to the question, find the width. Well, the width we know is 6 centimeters. And the height is 3 centimeters.